So myself, Dr. Satya Pramod Jammy, I'm the coordinator for the Center of Excellence in Electronic Cooling at SRM University AP. We have Dr. Prabhakar Subrahmanyam with us here. He's a scientist at Dell Laboratories USA, and we welcome you, Prabhakar.
Thank you.
Today we are going to discuss about few things and why is electronic cooling an important thing in the current scenario, Dr. Prabhakar?
That's a great question. So if you see in our lives, electronics is something that we use on a daily basis. Be it your smartphone or your smartwatch or your AR/VR devices, everything is driven by electronics, and they're all driven by your CPUs and GPUs. As the photolithography process improves, right, scaling up of Moore's law, you're packing more and more transistors into the microprocessors, and more transistors means it's more power, and more power is more heat, and which is why we need to cool these electronics, right? And there are different techniques of cooling electronics. So be it a smartphone or all the way to the high power device in the data center, all that needs to be cooled effectively, which is why electronic cooling is of paramount importance today for all of us.
What are we planning to do at SRM AP or SRM University in general? Because we are trying to run a program to make students that they understand this. So can you tell us about that program?
Sure. Like you rightly pointed out, it's a multidisciplinary in nature. Electronics cooling is not specific to electronics engineering students anymore, because they need to have a fair amount of understanding on heat transfer, right? And they need to be able to simulate these things in heat transfer, which means they need to have a solid fundamental foundation in computational fluid dynamics. And they need to be able to model these things and then bring it into ice-pack thermal software. And to be able to introduce your course like that and tell them that, hey guys, this is how it's got to be cooled. We don't have any structured program in any university today. And then in the past, when I used to hire a lot of interns at Intel, right, I used to teach them about simulation. I used to teach them about experimental methods in cooling all these domains. And the students actually spend a good chunk of 6 months with us in our labs at Intel. And then they learn everything from chip design cooling, from client devices, SoCs, desktop processor, laptop processor, server processor, HPC, GPU, all the way to the layerless machine learning GPUs. They learn pretty much everything to cool from 2 watts all the way to 2000 watts. I thought about it, and then I was talking to my vice president and said, look, instead of the students coming to the university, from the university into the industry, and we train them, why don't we go directly to the university and train the students? That was the spark, that was the initiative, right? And I spoke to our president, Dr. Satya about this, and I said, can we actually start a capstone program? So whether the students come to us or we actually go to the university and teach them. And that's what the capstone program is. Instead of a traditional textbook method, this is going to be a non-traditional, hands-on practical training initiative.
So given that this is an industry internship within the classroom environment, I know I can understand the students will benefit a lot by taking this thing. And using this as a base, what would be their higher studies opportunities or opportunities in the areas of research in industry?
Yeah, it's a fantastic question. I mean, it opens up doors for a plethora of things for them. They can actually directly go to the industry, but if students also want to do research program further to enhance their skill and learning about and get an advanced degree, that's more welcome, because in the United States, the renewed international focus right now, not just in the US, everywhere, even in India, is a semiconductor consortium, right? They actually want to spread the semiconductor consortium and open up fabs everywhere. And even it's national interest of India to actually do semiconductors.
So this is a wonderful opportunity. In short, if I can summarize, so this course will act as a base for them to get ready for industry or to grow and prosper in the area of electronic cooling, which includes not only just cooling of devices, but there are other things like HPC, parallel computing, where you can understand how things are cooled at a granular level.
That's correct. This program is going to be a launchpad for them. They can launch themselves into directly go to the industry and then and work on cutting edge technologies, right? And all the way leading to quantum computing. Or if they want to further their skills into research, and this course will basically open up their eyes and then say, oh, this is exactly how things are getting done. We directly come into the campus and then we teach them about the application. And that way it actually opens up their spectrum of enhancement. of knowledge, right? So they can go do any kind of research that they want to do, because this program is a purely multidisciplinary in nature, like you observed in the start of this meeting. That's how it's going to be.
Thank you, Prabha. Thank you for coming in.
You're most welcome.
And giving us this opportunity for the capstone.